Okay, I want to develop the idea of elementary matrices. We start with the matrix A, and we're just going to row reduce this down to the identity. It's very easy to do. And we're going to keep track of our steps here. We're going to keep track of what we do. So the first thing we do here, well, we want a 1 here, so we take 1/2 of the first row, and we denote that by saying 1 times 1/2. We write that next to the first row to indicate how we got this, okay? So that's going to give us clearly 1 3/2. Take half of the first row. Okay, then we want to get rid of the -5, so we're going to add 5 times the first row to the second. Well, we denote that by 5 times row 1 plus row 2. And we put that next to row 2, so we know that that's what goes into row 2. So we do 5 times this row added to this row. 5 times 1 is 5, minus 5 is 0. 5 times 3/2 is 15/2. Plus the 1 we have here, that's 2/2, that gives us 17/2. Then we want a 1 here, so we take 2/17 of the second row, and we get the 1. Finally, we want a 0 here, so we add -3/2 of the second row to the first, and we indicate that 1 times -3/2 times the second row, and that's going to go in the first row. Okay. Now we've got these things called elementary matrices. Now we haven't done this yet, but let me kind of separate all this stuff from this, because this is where we go next. Okay, what we did to the A matrix here in the first step, we're going to do to the identity matrix. So we take first row times 1/2 into the first row on this matrix, gives us 1/2, 0, 0, 1/2. That's our first elementary matrix. We're going to call that E1. And then we're going to multiply this matrix by E1, and you can easily verify that if I do 1/2, 0, 0, 1/2 multiplied by this A matrix, then I'm going to get this. So that's E1 times A. Now, second thing we did was 5 times the first row added to the second, replacing the second. So we do this on the identity again. We do 5 times the first row, we get 5, 0, added to the second. 5, 0 added to the 0, 1 gives us 5, 1. There's our second elementary matrix. And now we multiply the matrix that we got here, the E1A matrix, by E2. Multiply this matrix by E2. And you know, I wrote that wrong, and I'm going to fix that before we get confused. Matrix multiplication isn't commutative, so I've got these all written wrong, although we did it right, so let's write it correctly. E1 multiplied by this matrix equals this. So that equals this. And then E2 times this equals this. E3 times this equals this. And E4 times this equals this. Okay, so I can say now that this matrix is E1A. And then E2 times this matrix equals this matrix, which is E3, E2 times E1 times A. And then E3 times that, and so forth. And I end up with E4 times E3 times E2 times E1 times A. And what we got was the identity matrix, so this sequence E4, E3, E2, E1A is equal to the identity matrix, it follows immediately here that this product here with A giving you the identity, this product is the inverse of the matrix A. So we've got another way of inverting the matrix A that kind of justifies, it does justify how we did the row reduction to get the inverse matrix. So from this, we could also say that A equals E4, E3, E2, E1 inverse times I. In other words, if we multiply on the left this sequence by the inverse of this sequence of matrices, we're going to get the matrix A. And of course, I wrote this down carelessly. I think I just didn't finish it. And multiplying this sequence E4 through E1 inverse times I gives us E4 down through E1 inverse. So A is the inverse of this product, and that means that A inverse is this product. So there we have it. So I've asked that we multiply these matrices out, and let's see how that worked out.